Okay, by the way, do you guys have any issues with my audio right now?
No.
No. Okay, good. So let's start with today's class. And here our main objective is to start from the very beginning of vectors, matrices, and different algorithms we can employ to basically do matrix manipulation. Okay, चलेगा? And I do want some level of active participation from both of you. So try to like spam whatever be your thoughts. Now, first thing is basically this one. Uh, this is a list, right? You both of you have done a list. So, Dupika, are you comfortable with list?
Yeah.
Okay, good. So, this particular thing is like we are defining two vectors, and we can name it anything. So, in computer science, you might say that a vector is like a list of different elements. Now, the number of elements will define the dimensionality of the vector. And we can do a vector sum, but understand that what I'm saying, that vector is a list of elements. It's a very what you call niche way of basically a very क्या बोलूं, थोड़ा सा basic हो गया, थोड़ा सा ज़्यादा ही basic हो गया. And this should not be like that. So that's why I recommend both of you guys to go and watch the videos of Three Blue One Brown. That guy has done a fantastic job in basically creating a playlist which is so much advanced in this, like to have more people understanding what vectors and linear algebra is. Okay, understand that this particular topic in both your computer science as well as in your physics classes will lead you to a more advanced topic in your mathematical courses, which is linear algebra. Okay, so okay, before beginning, I do have a very simple thing to ask both of you. What do you guys want to be in the next 2 to 3 years? Do you want to take, like, which course are you guys planning to?
Depends upon my rank.
JE rank के ऊपर डिपेंड करेंगे. Good enough. What about you, Dutika?
हाँ.
Same maybe.
Same. What's your aspiration? तुम like aspirationally क्या करना चाहती हो, ये बोलो. Like ऐसा तो नहीं कि तुम्हें इंग्लिश ऑनर्स करना है. अगर ऐसा है तो वो भी बोल सकते हो. Whatever be your मतलब wish, क्या करना है वो बोलो.
Can we skip this part?
Can we skip this part? Okay. Yes we can, but suddenly क्या हो गया? Just asking, क्या हो गया भाई?
Nothing, just skip it.
Okay, okay, fine, चलेगा. Just give me a second. I need to send one. Okay, there is this again file manager. Hi. Give me a second. This file manager is doing stuff. Just give me 1 second. Mm, yeah. Okay, let's not ask any kind of questions like that, and let's directly go. So देखो यहाँ पे दो factors को list कर दिया. अब then we can use a vector sum. Now how do we sum vectors? Okay, so we can take the ith component. Okay, like 1, 2, and 3, and we can do a simple sum like 1 plus 4, 2 plus 5, and 3 plus 6. Okay, and this kind of vector sum is basically like each and every element is being summed to its corresponding element at the same location. ये तो समझ में आ गया. So now how do we do it? This is a single line way of doing it. Of course you can like basically have like this thing written out in a different format. So I can just write for I in basically range length of the vector A. Okay, And suppose if the length of the vector A and vector B don't matches, then it must be the same for addition and dot product. Now, if they're the same, then uh, we can actually use elif. Mm, because these are both of them are the same, so we don't need to just go into that part. We can just simply do a summation, sum results. Okay, and we can just add it. Okay, that's it. We are just taking the ith component and adding it. That's the simple part. Okay, and now how to do it in a single line. This particular line explores how to do vector addition in a single line. So if you just have these two vectors mentioned with the I variable inside a list, because we want it to be a list. Okay, and we just do a simple vector addition with it. For I in the range of the length of the vector A, it can be vector B because both of them have been initialized to the same length. And what is the dot product? डॉट प्रोडक्ट मीन्स वहीं 1 को लो, 4 को लो, दोनों को मल्टीप्लाई करो, 2 को लो, 5 को लो, मल्टीप्लाई करो, 3 को लो, 6 को लो, मल्टीप्लाई करो. ठीक है, दिस इज कॉल्ड अ डॉट प्रोडक्ट. रिमेंबर दिस. ओके, दिस इज नॉट वेक्टर मल्टीप्लिकेशन. जो मैट्रिक्स मल्टीप्लिकेशन होता है ना, दिस इज नॉट दैट. आर यू गेटिंग? दिस इज नॉट द मैट्रिक्स मल्टीप्लिकेशन एल्गोरिथम.
Okay.
This is called dot product. And you have done right. I dot A O.
Yeah.
Yes. So वहाँ पे do you remember that what suppose I had two vectors, something like this. Suppose in your physics classes you might have say done some vectors, say A with some vector. उसको तुम ऐसे कर सकते हो 1i plus 2j plus 3k. ठीक है, और फिर ले लो B equals to something like, sorry, what is happening? Okay, something like this. Then suppose what should be the dot product A dot B. What is the answer that you get? You basically do a multiplication like this, right? You multiply 1 with 4, 2 with 5, and 3 with 6 here. Because they have the same numbers, or let's say representation, I with I, J with J, and K with K. Now, why do you do that? Because this is a dot product. And you can actually, instead of representing it like that, you can represent it like this as well. 1, 2, 3. And you can represent B as like this, and then do the vector product, and this will be exactly the same. Do you understand? Then instead of I, J, and K, you remember that these I means basically the first position, J means the second position, K means the third position. Understandable?
Yeah.
Okay. Now, after all this, like I'm going to comment this out. This is basically for your understanding. Do you have any problem with this?
No.
Okay. Then this is the dot product that we do. Basically, we do the multiplication, and after doing the multiplication, we sum them all up. So this is the line that we do, and this is single line in which we are doing. So guys, take a look into the single line way of doing it. If you have any issues or like प्रॉब्लम हो रहा है सिंगल लाइन में करने का, मुझको बोलो. समझ में आ रहा है?
হ্যাঁ
Duti-
সব
Okay, Dutika, single line is it too complex?
Yeah, it's okay.
Fine, समझ में आ रहा है? Okay. So what we are doing, we are creating a list. In the list, we are taking each and every element at a particular position, multiplying them, and then finally in the list we are having the sum function. Now if we just run it, so the addition result is of course like 1 plus 4, that's 5, 7 and 9. Is it 5, 7 and 9? That's correct. Now if we just do the 5, 7 and not like that, we have to multiply, that is 4, 10 and it is what, 20, 24. 4, 10 and 24. If you add this up, then it is 4, this is 10 and then, oh sorry, 24 came out. this is 18. That's why 18. So that is 32. Okay. So yeah, this is how you do the dot product. But understand that what we are doing, we are using a simple list, right? We are using a simple list. But this is not how you should be doing vectors in your what do you call this? Python. This is generally how you should be doing this. Okay. You will use this particular NumPy module. Okay. Dutika, do you have any issues with we are now starting with the modules and
No,
explaining the things?
but you told not to use NumPy.
Not to use NumPy मैंने कब बोला?
क्लास पे आ जाए.
NumPy okay, no, do not use NumPy without the permission of your teachers. Like basically in your courses, I don't know like where how your courses are being handled, but generally schools don't teach much of these modules in your class 11. I don't know about 12, like पता नहीं कितना तुम लोगों को modules सिखा रहे. I just want you to understand every concept clearly. I don't care about what your current school is teaching. This is going to be way more advanced than what your current school is teaching. Okay, and that's it. That's what I have to say. Now let's go. NumPy is actually a module which is written in C Python with specific focus on accelerations. Accelerations means performance. Basically, it is written in C++. Okay. Now, how most of it is written in C++. So that's completely written in C++, but most of it is written in C++. Now we are creating arrays. Okay. Now these arrays are basically NumPy arrays, and these NumPy arrays are, if you just see clearly, they are being taken from different. This is the like array definition in like you can actually just click on it and see real world applications, but see that this array has different properties. Okay, but understand that this array is a C object नहीं बोल सकते, but this is defined in C programming language, and in C programming languages these arrays are allocated memory continuous. Okay, so these numbers 1, 2, and 3 in the memory of your, let's say, RAM, like I want to use the term heap. In your heap, these are given a contiguous space, means one after another, each and every element is located. Now, why that matters? Because it basically helps in improving the performance of your vector addition and vector product. Okay. And here what we are doing, we are basically doing the same thing. We are doing the vector sum. Okay, we are just taking vector A and vector B, we are just adding it up. And we are just taking the dot product. Okay. And this is the 2D part, but yeah, just give it a second. I'm just going to, before going to the 2D part, I'm going to comment it out. And as you can see, I've taken the same matrices 1, 2, and 3, 4, 5, and 6. And in the list, I've also taken the same one. Now, in your command line, if I use time, then Python, and then basically run the code, basically I go here and vector with list. So as you can see, it took about let's say it took about total 0.019. Okay. Now if I just do the same thing but with, let's say, NumPy. Okay. It is currently okay. This is another issue. How okay, so Python currently I'm using the Python 3.13, and Python abstracts a lot of the different information in this. So understand this part. It is only taking 97% of the CPU. Okay. Whereas as soon as I use NumPy array, it is using all of them, like most of the resources that are available to it. Okay. But I need to basically increase the dimension for it to get you a real world difference. Give me a second. Let me show you a few applications of it. Okay. NumPy array performance. versus Python. Yes. So if we just go into some images, see this one. This is a good one. Why one should always use NumPy arrays over built-in lists for mathematical operations, especially for relatively small square matrices. Okay. So here, this one person, this one, not this actually I think Python's /Python official one. Someone actually posted on Reddit about this. So if we just go on to look at the performance analysis here, you can see that as the square matrix size grows, okay, the time, average runtime, here n equals to 5, so uh, average runtime is increasing in seconds, okay. So as soon as you hit like 3000 matrices, the dimension of the matrices, you are expecting 4 seconds for it to compute. But suppose you use NP array and it goes to 3000, you are still within 0.01 second to 0.02 second. Do you get it? As soon as you like basically go to a like higher dimensions, which you like especially need to go when you go into various machine learning tasks. So there you will see that the performance of the array is almost like what, 10 times, not even 10, 20, 20, 200, 200 times. Yeah, it's about 200 times faster in this particular example. So was I able to make you guys understand this part? Why you should use NumPy arrays in real world use case?
Yeah.
हाँ
Yeah. Okay. Now coming to this, coming to the what I am seeing in my terminal, I am seeing that suddenly, okay, that should be what we are doing, right? But we are getting a result which probably doesn't make sense. It is not exactly what it should be happening. Like this is taking way lesser amount of time than the NumPy one. And why is that? This mostly has to do with how Python 3.13 behaves. Understand that after 3.12.8, so that is like the last Python version before 3.1, 3. Like 3.1, 3.4. I know like it's very weird. Let me just say which Python. This is the Python, and if I just say Python version, so oh, I'm currently using 3.13.3, not the 4 version, but yeah. So here it has implemented JIT. JIT means just-in-time compilation. So JIT compilation kind of messes up the performance with how normal NumPy libraries and everything should behave, and that behavior has to do a lot of with how compiler architecture works and all this. So as you guys will probably learn in your later like years, these are stuff that you don't learn in your school level. I'm trying to bring some advanced stuff into your school level. So just understand that this part relates more to how compilers behave. Okay, on different systems. I can't like replicate it again. Problem. So that's it. Now in the NumPy one, I was going through the NumPy one. Understand how different vector summation are done. This is matrices. No, this is not the one. Just a second. This is the NumPy. So here I don't need to do a for every element. वो for loop नहीं है इधर. You can just do a simple vector addition. Okay, like with this plus button. But फिर again, how this is working at the back end, it is actually like if you just see the add function. This is the add function, and at the end of the day, this is doing what like other like your list implementation was there. It was doing this for I in range and all this, But NumPy wala, this is abstracting that information, and using a simple add function itself, you can do it. Now, suppose I change it. I change it to something like, let's say, 7. Now, if I just run it, what will happen? So let's run it. It will give me an error. Operands could not be broadcast together with shapes. So what do we mean by shapes? Shapes basically refer to the dimensionality of the vectors. So first vector dimension is 3, and the second vector dimension is 4. Okay. So this is an error that I want to show, and see, this is the value error. Now, this is an example where we can do one thing. Try. This is vector sum except this. Now, if I just basically have this thing commented out. Okay, what is try? It is trying to do the vector summation, and if it succeeds, then it will just print the vector sum. But suppose there is a value error, and you are catching value error in a string called E. Then you are just printing error in vector addition E. Now let's do a run. Here, as soon as I did that, okay, did I run it? No, sorry, it did not run. Yeah. So as you can here, see, it is running it like this, not aligned. More verbal, call this, answer, because I am writing error in vector addition. Now you might say, okay, if you are confusing like what is getting printed, I'm just doing some random stuff so that understand. If I run it, this is the print statement. Then it is normal one. Okay. Then it is basically going into the next one. This is the next part, the dot product. This is the error from the dot product. Why? Because even though the error was here, it caught it and it was able to let the compiler go to the next part. So if I just do a simple print statement, print, let's
এররটা
say,
হচ্ছিল না
because dimensions are not the same. Next line. Okay, just simple next line. Now if I just run it. So as you can see, because of the try and except block, the program was able to progress. Even though there is an error, the program was able to progress to the next line. Do you get it? Why you should be
ইয়েস
like writing try and except in your program is so that if you want your program to run, let's say even with a few errors, it should not stop. Then you should be using this try and except catching phrase. Okay. चलेगा?
চলেগা
Okay. Now let's not do any of this. Uh, let's have a simple dot product here. And of course, I'm going to reduce the dimension. But suppose I want to do something like different. Suppose I do 8. Okay. Now, both of them are the dimension same. They are of the dimension 4. Okay. Oh, sorry. I think this got also commented. Like this should be in the comments. So yeah. Now, vector addition using NumPy arrays. This is the final result. And this is a dot product result. Okay. Now the dot product is very simple. You just do np dot, मतलब np, उसके बाद normal वाला dot, उसके बाद लिख दो dot. Okay. This is the dot product. This is the dot product of two arrays, specifically A and B are one-dimensional array. It is the inner product of the vectors, which is without complex conjugation. Oh, Dudika, have you done the complex number chapters in your syllabus?
Not yet.
Not yet. Currently, okay. How many math chapters have you done? Can you just let me know so that with that we will scale.
We till the quadratic equation.
Okay, have you done sequence and series?
No.
Okay, fine. So
But I
quadratic
know it.
equation, you know, okay, very good. In your physics, have you done, uh, like, have you tried finding out the area of a parallelogram of using vectors?
No.
It's basically the determinants. Okay, so that's it. Fine.
Cross product A cross B.
mhm.
L cross B a cross product.
L cross B cross product. That's correct. So Ritika, how much of vectors have you done in your physics class? थोड़ा सा background देगा इसलिए.
I guess everything.
Everything में क्या क्या included है? वो तो मैं भी रेस्टोरेंट में जाके बोल दूंगा कि भाई हमारे रेस्टोरेंट में सब कुछ मिलता है. फिर मैंने पूछा कि अच्छा आपके रेस्टोरेंट में क्या ये फ्रेंच मंचूरियन कुछ मिलता है, फ्रेंच के साथ मंचूरियन खाना मिक्स करके कुछ मिलता है. वो उसको वहां पे गाली देके रेस्टोरेंट से निकाल देगा. सो स्पेसिफाई.
Resultant, uh, the resolution of a vector, dot product, and cross product.
ओके. तो डॉट प्रोडक्ट एंड क्रॉस प्रोडक्ट कितने बड़े मैट्रिक्स के ऊपर किया है?
Small.
अरे स्मॉल का मतलब उसका डायमेंशन बोलो भाई, 2 3 4 5 क्या?
I cap, K cap and Z cap.
ओके मतलब 3 डायमेंशन, थर्ड डायमेंशन, राइट?
Yeah.
हैव यू डन adjacent have you done any of the transpose of matrix or any of them?
স্যার ওগুলো 11 এ করা হয় না।
No, we used to do that. Adjacent निकालना ये सब.
না তুমি যেটা বলছো অ্যাডজাসেন্ট এগুলো ক্লাস 12 এর ডিটারমিনেন্ট ম্যাট্রিক্স এর ম্যাথমেটিক্স এর চ্যাপ্টারে পড়া ক্লাস 11 এ সব কোনো ম্যাট্রিক্স এর অ্যাডজয়েন্ট ফ্যাডজয়েন্ট কিছু পড়া
No, like that, I know that it was not there, but our school was mad. They used to teach us. That's
হ্যাঁ
right.
তোমরা ওয়েস্ট বেঙ্গল বোর্ড সিবিএসই বোর্ডে নেই
So in West Bengal board, generally we start with all of that. So it's fine if it's not done. We can just go ahead and understand how even those are actually working. Now, this is a simple dot product. Okay. And as I said, you have already done dot products. Now we can explore this part. This is your 2D matrix. Okay. Now 2D matrix means these vectors, what did they represent? They represented lines, right? Or let's say lines with some direction, which physics people are too much obsessed with, right? So, hey Dudika, are you a physics, like, do you love physics?
No.
No? Okay. Niket, do you love physics?
অফকোর্স
Okay, that's a good response. And Dudika, why do you hate physics? Just a question.
I do not hate it,
Then
but I
it's not
don't
your
like it
favorite.
either.
You don't like it either. Why? What's the reason? There should be a reason for not liking physics, right?
I don't know. Like,
मतलब थोड़ा ओके समझ लेते हैं कि फिजिक्स उसको पसंद नहीं है, but she is currently not able to get the answer in
আমার
words,
জন্য
right?
এটা আমার জন্য এটা কেমিস্ট্রি হিসেবে অ্যাপ্লিকেবল
Applicable. Okay, total আমি জানি. I know about you. So let's go. So just like simply doing different kind of let's operations on 1D matrix, we can do multiple operations
আচ্ছা
on
টেল মি
2D
ওয়ান
matrix.
থিং ডাজ দ্য নামপাই মডিউল ডিফারেন্সিয়েট বিটুইন আ ডিটারমিনেন্ট এন্ড আ ম্যাট্রিক্স
Determine, okay.
I am telling differentiation, not English differentiation. I am taking mathematical differentiation of matrix and determinants.
हाँ हाँ हाँ
Mathematical differentiation.
वही बोल रहा हूँ. So basically in your papers, okay Dutika, for you as well, how do you write a matrix and how do you write a determinant? So as soon as you change the matrix का जो symbol है वो दोनों brackets के जगह दोनों अगर, like if you just give a straight bar,
Straight lines.
straight lines, yeah, straight bar or whatever lines, it represents that you are doing a determinant function. Do you understand? You are applying a function called det, like det, det. That's the determinant function. In NumPy, there are different ways of doing it. I'm just showing you. Just give me a second. So if I go, suppose I go to NumPy, just search on Google NumPy functions to apply on matrices. Okay. And maybe go to any of the one. Manual would be a little bit difficult here because, okay, let's go to manual. Sometimes it's actually easier to read the manual. You can see this is a matrix function which converts strings into matrix. Okay. And there are different functions here. Yeah, methods. So यहाँ पे if you just go to determinant, do you have it? Currently, I don't think so. In the manual, I think we have to go to a lot of. See, these many functions are already there in the matrix. Okay, suppose max. So this is numpy matrix dot max. What it does, it finds out this is same as matrix. Okay, but returns a matrix object where the array max would return. And okay, this is not the thing. See the example. In the particular matrix, it returns the one value which has the maximum like magnitude. Okay, so if I just apply this here, you will find, but what we are looking for is not this. We're looking for determinant. So there is transpose, there is squeeze, there is sort. These are actually under matrix numpy matrix methods. So we
So
will
how will you find the value of the matrix by determinant? We have to find the value of a determinant, like not determinant matrix. We have to find the value of determinant. So there is no function to find the value of determinant.
no, there is. I forgot the exact name. I think it's numpy det or something. Yeah, linear al dot det. Yeah, it was there. So it has to be in the linear algebra submodule. So just give me 1 second and look into the manual and find the linear algebra वाला submodule कहाँ पे है? रुक जा. NumPy linear algebra manual. It should be here. Yeah. Okay. So here this is NumPy dot. This is vector dot. Inner product, outer product, and this is the tensor
Hey, what
dot.
is inner product outer product?
अभी के लिए समझ लो तेरा dot product और cross product.
Acha.
Inner product and outer product are very, very different stuff. Just give me a second. This is actually one more thing. This is a good one. NumPy dot diagonal. Okay. It returns the
A
diagonals.
diagonal matrix. What?
It returns the diagonals of A with a given offset. So the examples should be here. See, this is an array like this, and if you just apply the diagonal, it will return this diagonal. Suppose if you say the here main diagonals, so you have to do pass the argument. Main diagonals of the 2D array by skipping. Then if you just do one means the middle row access first. So
So
you
sir, tell
can
me one
actually
thing. Yeah, tell me one thing. Okay, can you differentiate determinants in matrices? I am telling mathematical differentiation.
yes you can, and that you will do in your
But
quantum mechanics. You can you will do in your
না না
quantum mechanics courses.
কোয়ান্টাম মেকানিক্স ম্যাথসেই তো আছে আমাদের
Hmm, just a second. Yeah, this is the manual I'm looking. Okay, it was right there in front of me, and I couldn't get it. Okay, so this is the function numpy dot linear algebra dot det. This is the function you apply to the matrix to find the uh, basically determinant. Okay, so let's see. Let's go here. Let's try to find the determinant. Okay, hashtag finding. Let me just zoom in a bit so that determinant of a matrix. So this is currently we are using the first matrix. Let's use the first matrix and just print it. Okay, let's run it real quick. And here it is. The determinant of the matrix with using the number is -2. So -2 is for the first one. First one can this is
how
our
can it be decimal 2.00004
oh that is okay. Let let me show you some very
It
good
is pure
things.
multiplication. It is pure multiplication. How can it be decimal?
Showing it. Go to Python. You can add 1 plus 2, I think. Yeah. So it gives a good answer. 1 plus 2 is 3, right? If you do 0.7
আর
plus
জানলাম
0.3, it is 1. Now you do 0.1,
1.0.
yeah, 0.2, see the result.
না না এটা কি করে how is it getting that 4 in the end? What is the logic?
The logic is because any kind of these programming languages, they don't understand this 0.3, 1.0 or any of them written in decimal places. They convert it into binary. Now in your binary representation of, what is the binary representation of 0.3? Do you know?
পড়তে হবে ভুলে গেছি ক্লাস 11 এ শিখেছিলাম
Do
ফার্স্ট
it.
চ্যাপ্টারে
Do it, and it is a non-terminating representation. Means the binary numbers will just like pi. It will just go on. Okay. And the computer basically, the computer needs to slash the output at some point, right? Dutika, remember the rule?
ওকে ওকে
In the first few classes, we discussed that we need to stop the,
Yeah.
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 So the terminal, not the terminal, the Python program has to stop. And that stopping is decided on the number of bits that are already there. So as soon as it stops, and then basically the number is still in binary, right? It needs to then reconvert the binary into decimal for the output. And that reconversion, during that reconversion, because the number is not complete, right? It is a non-terminating number, and you have terminated it at some point, and that leads to this accuracy differences. Okay. Was it understandable?
या
ओके. सो इसीलिए यहाँ पे देख लो 2. चलो एक बार देख लो इसका डिटर्मिनेंट क्या होगा. 4 times 1 is 4 minus
-6
3.
4 -6 -2
Yes, but understand that it is doing it in a very different way than you might actually understand, because there are multiple performance enhancements which are going on under the hood.
okay, tell me one thing, what is the logic behind like finding the cross product, like it is equivalent to finding the value of a determinant without using numpy?
Yeah, without using numpy you do it now. So suppose we do
না
go to the list wala. Yeah, we
for
go to the
no
list.
no I'm telling
uh,
for n dimension for n dimension of determinants.
n means like, let's say it be 15, 1500, 15,000, whatever we like.
Yeah, yeah.
Yeah, so
Without doing numpy, I am finding the value of determinant, or you can eitherly say that yeah, I am doing cross product.
yes, okay. So
Anyhow,
up till now, how many, like, you guys were trying to find out the determinant, right? And up till now, have you tried finding the determinant of 4 cross 4 matrix?
হ্যাঁ 4 cross 4 করেছি
Which is, Dutika, have you tried finding out the 4 cross 4 matrix?
No.
Okay.
4
So let
cross
me
4 এর পর আমিও করি
uh,
ল্যাদ
do I have any good animation? Just a second. And currently I don't think so.
স্যার সত্যি বলছি এটা বহুত টায়ারিং জিনিস
Yes, it is tiring. So let's visit. I'm showing.
প্রত্যেকটা বার করে তার ফ্যাক্টরের সাথে ইনটু করে আবার তার ভিতরে একটা 3 ক্রস 3 ডাইমেনশন আছে সেটাকে আবার
Yes. So understand that you know it, but currently Dutika doesn't. So we need to just give a small brief over it. So this is a 4 cross 4 matrix. Okay. So you take the first element and you cancel out the row and the column. Okay, sorry, ulta dige. Ye row hai, ye column. You cancel out the row and column, and then in the 3 cross 3 matrix that is left out, you try to find the determinant of, or basically the cofactor of. Okay. And a multiply. So this is how it is done. A11 times the determinant of this one. Then okay, they have gone through the column wise, not the row wise. You can either do the row wise or the column wise, whatever. Here they have gone along the first column. So the next one will be 2, 1. So they have cancelled out this particular row and this particular column, and then whatever returns remains basically A12, then A32, then A42. This is 32 and 42. This particular part of the uh, matrix is now the cofactor for this one. Now you basically have to do an alternation. Alternation means plus, minus, plus, minus, plus, minus, plus, minus. And how it is done, this plus and minus? This is being allocated when the sum of I and j. I and j is here. I is 1, j is 1. So it is a even number. So if it is an even number, then it is plus, it is basically minus 1 to the power I plus j. Do you get it? Minus 1 to the power I plus j. So 3 plus 1 is 4. So minus 1 to the power 4 is a even number, so it is a positive. So it is positive. But minus 1 to the power 5 is basically negative, right? So that's how this plus and minus sign are determined. Okay, determined. And when you do the 3 cross 3 determinant for all the 3 matrices, okay, इसके लिए एक बार determinant निकालो, इसके लिए निकालो, इसके लिए निकालो, इसके लिए निकालो, निकाल लिया. उसके बाद इनको जो है पूरा लिख के सम करो. फिर लिखने के बाद you do need to remember that A11 term was also there. Then you need to basically add this. So this is the whole expression that you need to do. Do you get it?
Yeah.
This is how a determinant for 4 cross 4 needs to be calculated. Now, suppose it was 5 cross 5. Then what you need to do? Then basically it would be something like पहले यहाँ पे लो. Then suppose यहाँ पे there were extra rows. Then in that extra rows you need to find out, okay, A22. Then for A22s you need to find the like 4 cross 4. This is a 4 cross 4 matrix. Then for 4 cross 4 matrix you need to find its 3 cross 3 matrix. Okay, determinant of the 3 cross 3. So this is how it goes. It's a recursive function. Okay, do you get it? This is how difficult the
What do you
complexity
mean by
is.
recursive function?
It is recursive now. To find out the
The
determinant of a 4 cross
recursive.
4.
What
Yeah,
what do you mean by recursive?
to find the determinant of a 4 cross 4 matrix, you need to do the determinant of 3 cross 3 matrix.
अच्छा,
To find the determinant of 5 cross 5 matrix, you need to do the determinant of 4 cross 4 matrix, and then for each 4 cross 4 matrix, you need to find the determinant of 3 cross 3 matrix.
3 cross 3. And for each 3 cross 3, I have to also again do the 2 cross 2 matrix.
2 cross 2 and finally 1 cross 1.
Yeah.
So this is how it is. Like ऐसा करते हैं, it's a
Let's.
this is recursion, right?
Sir, any short method to do this 4 cross 4 matrix? And I can apply in
Yes,
my mathematics paper.
yes, there are methods which are shorter, like which reduce the number of computations, but they are too much confusing to apply in real world by humans. So those methods are generally applied
Yes,
by
sir,
machines.
it is also confusing. It is very tiring to do such calculations.
Of course, this is trying to do, but at the end of the day, like up to 3 cross 3 is fine. Now, okay, to
Yeah.
both of you have currently seen matrices composing of numbers, right? Kritika, तुमने अभी तक तो मैट्रिक्स के अंदर नंबर ही देखा है, right?
Yeah.
Complex matrix so high.
Now, हाँ, कॉम्प्लेक्स उसके अंदर भी तुमने नंबर देखा है. हमारे थोड़े साल बाद, okay,
Uh,
maybe after 2
like in
years. Yeah, yeah, बोलो.
there was a term for in AI in dimensionality reduction where the
Oh,
in the matrices you use words.
continue. You're correct. Continue. I want to
I
hear.
don't know anything more.
अरे बोलो. अच्छा ठीक है. So not going into AI, मैं कुछ और बोल रहा था, but let's continue from the part that you were saying. Dimensionality reduction means when you have information or data that can be represented using matrices, but the dimension of the matrix is like, let's say, 1,000 or maybe 1,100 or maybe like maybe what 50 million. Okay, something like that. Then you do techniques like LDA or PCA. Okay, and what these are? These are component analysis. Basically, principal component analysis means in the whole huge dimension, not all the dimensions are equally important. So you find out which dimensions are important for your analysis and try to just compute on those dimensions. Okay, these are dimensionality reduction, and there is one more term which is called the curse of dimensionality. Means as your
স্যার এসব
matrix,
কি আছে আমাদের?
no, it's not there. As your
না না, মানে
matrix,
যেই সিলেবাসেও নাই তো?
it's not there. So there is something called curse of dimensionality. Okay, what is curse of dimensionality? Curse of dimensionality basically means as your data grows larger and larger, the dimensionality of your matrices grows larger and larger, but it also makes your system smarter and smarter, but it grows exponentially slower and slower. That's the curse of dimensionality. Do you get it?
Yeah.
Okay. And I was just going to say one more thing, that currently you have seen matrices with numbers. In just few years, you are going to see matrices with functions. Basically, you will have different differential functions inside a matrix. Okay, where each and every term is a differential function, and you need to apply them on another function. Okay, and that's what we do in quantum mechanics. Those are called differential matrices.
আরে স্যার, from the University of Yale University YouTube lecture, I told you na. The professor told the best. He was the best professor.
Yeah, what did he say?
আরে তোমায় তো বলেছিলাম।
I don't remember half of the things with my life. How would I remember what you said to me?
Till today, I only know that I don't know quantum mechanics, but after someday you will also know that you didn't understand quantum mechanics.
Oh yeah, that's something. But yeah,
The
there are
professor, savage professor.
true. Okay, let's continue with most of this. Now we are done from this part. This is like basically using list. Then after this we have done this is this is scaling. Yeah, we haven't done this. Just give me a second. I think there is one way of doing it. Just give me 1 second. So I run this cell. It is installing. I think I installed it. Now it is installing it again. It is doing it again. Okay. Give it some a little bit time. Okay. It's connecting to it. This one.
Can you tell me one thing
Yeah.
regarding chemistry?
Bolo.
Where does chemical kinetics and thermodynamics conflict?
Hmm. The conflict in they never conflict. They basically are like
No, no,
partners.
conflict. You know, in over potential concept, it conflicts.
Oh,
In electrochemistry, no one potential over potential
it's
conflicts between chemical kinetics
no,
and
understand it's not
thermodynamics.
conflicting. It's giving two different products or two different. Let's say one might say that okay, product A will be
No, no,
faster.
thermodynamics is saying that the reaction is feasible, but chemical kinetics is saying that it will take infinite many time to complete the reaction. So that is
Let,
a conflict thing, right?
let me give a good example of this conflict. Okay. Like carbon dioxide is very stable, water is very stable,
Yeah,
and we are made of
yeah.
hydrocarbons. Okay. So
Huh.
thermodynamically, Okay, thermodynamically, we should all decompose into carbon dioxide and water. Okay, right? And
Acha.
it's a very
More stable
simple one.
state, more stable. Like more
More stable.
randomness. We will go to more randomness. Okay.
Yes, but then how are we alive? Why are we not spontaneously burning into the carbon dioxide and everything? Why are we not
Then is it a
spontaneously doing?
then it is a violation of second law of thermodynamics.
No, second law of thermodynamics will also say that okay, the entropy will increase, and it should be even the second law is saying that you should die. Okay, you should die. You should burn.
হ্যাঁ
Why are
ইয়ে
we
হ্যাঁ
not burning?
ডিকম্পোজ করলে তো এন্ট্রপি বেড়ে যাবে
So why are we not burning or dying right now?
so so it is a violation of second law. That means
No,
second law
it's
is
not.
not applicable everywhere.
No, it is not a violation. Understand that to go to that state, you need to
আচ্ছা
first increase your energy, means your activation energy. Okay. Basically,
okay
arg,
okay
arg lagane
rate
ka.
determining state RDS.
Yes, and that's the
আচ্ছা
issue. It will take like good amount of energy to get us to burn. So that's why they burn the bodies because and burning bodies requires a lot of wood and all
okay
this stuff. So yeah.
so you are telling
Okay.
that there is no violation of second law of thermodynamics.
No, currently not.
Okay
Okay, let's see.
continue.
Let's run the cell. So mm, yes. So here, see this. Okay, by the way, let me show you one simple trick. What I did here. So I just added this particular line has then person. Okay, it converts any Python file .py. Okay, any .python file into a notebook. So I can create different cells or like just in Jupyter notebook for my Python file. Okay, it helps me. Let's say give you a demo of all of this. Okay, so here it was step 2. Then we did the step 3 and then introduction to NumPy. Okay, we were doing the scalar one. So this is your basically step 2 के बाद. Yeah. So let's do यहाँ पे कहाँ रख दिया? Okay, I think I did I run subtraction के बाद जो है scalar multiplication. This is addition. Where is this? Let's run this cell again. Okay, I'm not able to find it. Subtraction हो गया. Oh, okay. There's a scalar one. Scalar multiplication. Yeah, somehow I was actually missing it. So see here. Using simple list, this is the output that I'm getting. Why is it whenever I'm pressing this one is saying wait. Okay. Something is not right. Let me just run the code at this one. Okay. Let me just run the code. The name is Matrices. So as you can see in the step here, this is scalar 2. What we are doing, we are actually using the scalar to multiply all the values inside the matrix. Okay, so it is scalar multiplication. Okay, we are scaling. Okay, fine. Chalega?
चलेगा
Okay. So after this, we are doing the dot product. We have already done the dot product. We have done the.
oh no
This is a
please tell the cross product.
yes. This is another nested list. But do you want to go to the cost product real quick? We
अच्छा ठीक है
will
continue.
let's go one by one. Okay. Now after the dot product, this is actually using the Python list. This why we are using Python is to show you the algorithm for it. Okay, so dot product done. उसके बाद जो है nested list. So this is a nested list to represent a 2D structure, मतलब two-dimensional array. Okay, but here we are not using an array, we are using a list just to show you the algorithms that are necessary to go through the different like operations on the matrix. So this is the summation algorithm. So here what happens in the summation algorithm. By the way, Dutika, please understand that this kind of questions will be there in your class exam. Okay, like तुम्हारा school का exam. So please pay attention to this part. Okay, you need to write the suppose two matrices are given to you. The questioner will ask you to find the sum of the matrix or find the, let's say, matrix multiplication, and you need to implement this particular line, just one line, and it's done. Okay. So this is a line which might be a little bit convoluted. So let me expand this. Expanding
Yeah,
of
what
the
do you mean by convoluted?
convoluted means पहले देख के समझ में नहीं आ रहा कैसे करना. ठीक है. Understanding
Your
the
vocabulary skills are epic.
huh?
Your vocabulary skills are epic.
Okay, that's not so important here, but thanks. Okay, see. First, we have the for I in the range of the first matrix. Okay. Acha, by the way, you can add a checker as well. That this kind of multiplication will only be possible when, do you know, like we can't
The
add
order is
them with,
same. The order is
yeah, when,
same.
yes, the order is same. So we can't do addition on, let's say, n cross m with some p cross q. We have to have the m equals to p kind of matrix, right? Rudika, you know that, right?
Yeah.
Okay. So you can add a previous check that are the matrices multiplicable or let's say additional, like are they addable or something like that? Okay, basically, is addition possible?
No, so you are telling multiplication means scalar multiplication, right?
No, scalar is done. Now we are doing addition. Okay, to
So for
basically
addition, the orders should be same, and for no
addition.
for matrix multiplication, the orders might be different. But the like the m cross n condition for my matrix multiplication is m cross n. It should be the
Uh,
order of first matrix, and second matrix should be n cross p. That is the case. So
yes,
order can be
yes.
different,
No,
but like
order must be like this. N cross M and the other one will be P cross Q, then M must be equal to P for the matrix to be multiplicable.
ha.
Or let's say to be
Yeah,
like
but
not
but
to be
but for
multiplicable, but
addition,
for
the both of the thing will be equal.
addition, both of them needs to be the same. So M must be equal to P and sorry, N must be equal to P and M must be equal to Q. Okay, fine. Now here what we are doing, we are basically taking I and J as the indexes. Okay, so after taking the indexing, we are just doing a simple summation. Okay, how we are doing the simple summation? Basically, we are taking this particular element a I comma j. So for I in matrix A will go from 0 to 1 and j will also go for 0 to 1. But here understand, when as you print that a I comma j means you are doing 0 comma 0. So this is the first element I, that is like 1, and a matrix B element which is I comma j. So this is 0 comma 0 which is 3. You are adding this element and this element. Okay, and to get the summation matrix. Okay, and how do you get the summation matrix? You basically need to do the summation itself here. So matrix sum equals to this summation. Okay, fine. And now all these things, these are 3 lines, right? 3 lines can be done in a single line. That's the point. 3 lines of code can be done in a single line, where you just mention that what is the operation that you are doing. You are taking the two matrices and summing it up inside a list. Now in the first list, it should be for j in the range. Basically you go upwards. So this is the logic. This is a simple logic. So you go from downwards testing. So you go from downwards, the first loop is for j in the range. So apply for j in the range, and then after that, what is the next nesting loop? That is for I in the range, and then you apply for I in the range. This is a single line application of this particular like multiple line application. Okay, so is the single line application of this multiple line logic clear to both of you?
Yeah.
Okay, can you guys do it if left to your own will? Can you guys do it?
Maybe yes.
Yes. Okay, what about you, Jyotika? Is it fine?
Yeah.
Okay, good. Oh, by the way, I haven't given you guys any homework for a long, like quite a while. I shall be giving you
No, no,
some.
give Kelly Hamilton homework today. You told
Yeah,
na.
after, yeah, Callie Hamilton one. Let's do it. Let's in the homework we will keep Callie Hamilton, but for that we need to complete till the determinants. Okay, we need to go till the determinants. So that's what. Okay, let's see. Next is the matrix subtraction. Okay, subtraction is basically the same instead of like in our line, instead of having the plus here, you basically have the minus here, and the rest of the stuff are exactly the same. Okay. नेक्स्ट स्केलर मल्टीप्लिकेशन यूजिंग दिस इज एक्चुअली स्केलर मल्टीप्लिकेशन में क्या होगा यहाँ पे बस चेंज हो जाएगा लाइक इंस्टेड ऑफ हैविंग like two matrices having summation and subtraction, you have a scalar value which is here 2 multiplied to each and every element of the matrix. That's it, done. This is scalar multiplication. Then this is the main thing. Understand that this is the most important thing that you will be doing because this will be given
আচ্ছা
in
স্যার,
your
tell me one
versus.
thing, একটা
Yeah,
জিনিস।
just I'm not going to go to the explanation. Let's create a talk tree and then
স্যার
we talk.
বলছি, স্যার
Yeah, well,
তুমি কি ওই লজিকটা ইউজ করবে? একটা লজিক আছে না যে দুটো মাল্টিপ্লিকেশনের নেট, যে আফটার গেটিং মাল্টিপ্লিকেশন, ওই মাল্টিপ্লিকেশনটা আই এথ জে এলিমেন্ট হলো সিগমা, মানে সিগমা এ আই আর বি বি জে আর, সরি আর জে আর is equal to 1 to n. n is the order of the net matrix after doing multiplication. তুমি কি ওই লজিক দিয়ে করবে ওই জিনিস? সেটাই তোমায় জাস্ট জানতে চাইছি।
না না আমি তো লজিকটাই বুঝতাম না, তুই আরেকবার বলতে পারবি?
দাঁড়াও,
আরেকবার
তোমায়
বল
আমি
বলছি।
বলছি। আই এফ জে এলিমেন্ট অফ
হ্যাঁ,
দা, ধরো এ ক্রস বি করছো, তুমি ধরো
yeah,
এ
yeah, it's
ক্রস বি
fine.
করছো, দুটো
I a j element, yeah, then
আই এফ জে এলিমেন্ট অফ সি, ঠিক আছে? আই এফ
yeah,
জে এলিমেন্ট অফ সি ইজ ইকুয়াল টু সিগমা এ, সিগমা এ মানে হচ্ছে এলিমেন্ট অফ কিন্তু এ, ঠিক আছে?
okay,
সিগমা এ,
হ্যাঁ,
সিগমা এ আই আর বি,
r, okay,
বি
oh yeah,
বি
yes, yes,
জে, বি আর জে আর is
yes,
equal to 1 to n, where n is the order of
uh,
matrix of C. এটা আমি এটাই
I
বলছিলাম।
get it. Yeah, this is the basic algorithm of this is called naive multiplication. Okay, this is the naive multiplication algorithm for matrix multiplication. Okay,
কোনটা আমি যেটা বললাম?
yes. So understand that
আচ্ছা,
that one is a simple like guys. Okay, Dutika, have you multiplied two matrices? Have you done matrix multiplication?
I think so.
नहीं, अगर नहीं है, अगर नहीं किया है तो वो भी बोल दो. It's fine. Is it a yes or no?
Okay, just no.
No, okay. Then we can go over matrix multiplication real quick. No, I think there should be a visual tool. Say this, how this is done. Okay, let me just remap. So these are two matrices. Okay, this is there are two matrices. Now what we are going to do, we are going to multiply. So just take the first row, or let's say another column, and just multiply it with the first row of the second one. Okay, and by multiplying, what you do, you basically just take the first element and you take the first column ka element of the second one to the first row ka element, and then you basically multiply it, and then you take the second column element of the first matrix and the second row element of the first row matrix, first row of the second matrix, and you multiply it, and then you do a summation to
স্যার
get the
স্যার স্যার
first element.
তুমি ব্যাপারটা
Yeah,
উল্টো করলে, মোস্ট প্রবাবলি।
yeah, probably first and second matrix.
Row
Maybe
of first, row of first matrix into the element of column of second matrix.
yeah, row of first matrix into the column of the second matrix. Yeah, did I say the opposite?
হ্যাঁ তুমি অপোজিটই বলছো, রো অফ
Oh,
সেকেন্ড ম্যাট্রিক্স বলছিলে বাবা।
okay. Row of second. Sorry. That is the column of the second matrix. So here, as it then do the sliding. Basically, it slides down like this to find the final result. I think there are more visualizers. We can just wait. Is this attention model? Yeah. So, wow. Here's an animation. Let's see. Oh, this is like a huge multiplication that is going on. Okay. This is different. This is
এগুলো দেখছি অকাতের বাইরে পুরো।
no. Like that one was okay. 3 blue 1 brown has a mismatch. This is matrix multiplication. So this is okay. This is the lessons under. So the videos that I send about 3 blue 1 browns code playlist on the is taking the playlist and basically explaining different parts of the playlist here as well. Okay, so here it's doing the composition as a matrix. So it's just showing how matrix multiplication is going, but I want the better visualizer for matrix multiplication. Let me see.
স্যার তোমার কাছে এটাই, তুমি যেটা আগে সেই ক্লাস এইটে তুমি যেটা পিডিএফ সেই জিনিস লেখাতে না,
ওইটা লেখা বেটার হবে, রাইট?
আরে পাতি গ্রাফিক্স ট্যাবলেটে লিখে ওকে বুঝিয়ে দাও, হয়ে যাবে।
আমার কাছে এখন তো গ্রাফিক্স ট্যাবলেটটা কানেক্ট করা নেই। I have to connect it, so that's the issue. Okay, next time that's a good point. From next class onwards, if we have to write anything, we have to use the graphics tablet. Okay, just let's go with
তুমি
this
মাউস দিয়ে
simple
লিখে
one.
নাও, মাউস দিয়ে লিখে নাও।
Mouse is it will take like hell lot of time. So Dudika, just understand that you are taking the see, you are taking the first column of the second one and the first row of the first let's say matrix, 2D matrix.
I
Okay,
understood it.
okay, really?
Yeah.
Okay, then it's fine. You have seen multiple animations over this, then it's fine. Okay, I think this is the perfect time we can go and explore the zip command. Or should we explore? Zip will not be taught in your school. Okay. This is a function that will not be taught in your school, but it's fine. See, how a zip command functions is basically it works on any kind of iterables. Iterables means whichever has index, not necessarily index, like any kind of possible, like like for I in the list, for J in the list, we are writing. So that I in the list is now able to traverse and get the values of different items in that particular composition. Because it can access different compositions by just incrementing the value, these are called iterables. Means the like data structures over which we can take the different like elements of it by just iterating over one value. So as you can see, this is
So it's better we can create dictionary, right? We can create dictionary. Why are we using this zip
dictionary.
function?
No, zip, understand how zip helps. It creates uh, something like a dictionary, like I'm saying as something like a
So yeah,
dictionary.
something. So we can use that instead. Now why is it?
No,
Like John
suppose,
will be the key and value will be
good
the
point,
85.
good point. But in your, let's say, numerical data, you can't have dictionaries like that. Okay, you need that traversal. That zero index means something. In dictionary, there is nothing
Oh,
like
okay,
zero
okay, okay.
index.
No
In dictionary,
indexing, no indexing. Okay, okay, got it.
so that's why you need something like a tuple inside a list. Okay, zip basically
Yeah, yeah.
couples the two things together, where basically names is the first item, first tuple, and it takes the first score. So John with 85, Paris with 90, Bob with 78, Lucy with 92. It creates a tuples, like list of tuples. It's a list, and these are tuples. Okay, that's how zip works. So it's a very simple one, but it also has various applications, because as soon as you like do a zip, okay, suppose you do a zip of just, let's say, one one item, then that will be basically a like one, this is what, 1 2 3, then it is zip of one means one, then it is missing, like waiting for something, two, then waiting for something, three, then waiting for something. Okay, but then as soon as you do zip A and B, then it is basically one will be zipped with A, two will be zipped with B. So that's how this
And
basically works.
oh, tell me one thing. If I like change the order, like zip name scores comma name, so will it also change the
uh,
order?
it will change the order. It will be score. Currently it is like score comma name, or let's say here, no,
Like
here
score
one
আছে, score আছে, নিচে যাও, নিচে যাও, score ছিল।
score. Let's go with here. Here, if you just run this
হ্যাঁ,
program,
হ্যাঁ, হ্যাঁ, score. I'm telling that if I write raise equal to zip scores comma name, so it also change the order
yeah,
of the
it
nested
will be,
tuple.
yes, it will be
Okay, okay.
85 comma 85 comma John and so on.
John.
You
Yeah,
can
yeah.
do it. We can do it. We can solve it right now.
Can it
Okay.
work with more than two lists?
Yes, you can. Let's create another. Okay, first let's do this changing, and let's create something like uh, matrices. Okay,
So
and
we can also create this list by running for loop, right? Why using
we,
this?
yeah, we can, but it is a simple function which makes your life easier.
Huh? But yeah.
Okay, so here it has changed it. Okay, now we are going to do another one, add another one, and let's run. Just give it a second. Yeah, see, Dudika, fine, chalega.
Okay, so the fourth element of the first and the second list were not included.
The fourth element. Oh, okay. Because I gave only three, right? So what happens when you give not the proper number? Okay, it basically concatenates it to the one list which contains the least number of elements. So if I forgot that there are four things. So suppose I just give it like this. Now if we just compile, now the last element. Okay.
Yeah.
Okay. So this was just a simple example that would be necessary for this one. Now here what we are doing. We are doing the zip function, right? Using the zip function, we can just take multiply a and b. So what are a and b? A and b were defined to be kahan rakh diya? Hmm. Okay, matrix A and B. Okay, we are passing it. So this is a function that we are creating. Inside that, when A is a 2D matrix, B is a 2D matrix. Okay, this is a list of lists. So this is a list of lists. So there, what we are doing, we are using the zip function to basically take the first row, like row of the first matrix with the column of the second matrix, and we are taking each and every element and multiplying it, and उसके बाद जो है बाहर एक sum function that है, the summation is there, but understand that how we are getting that each and every element. So we are getting each and every element from this function as well as this function. This is the, remember that I was saying here, you go from the bottom. So this is the first nested loop. This is the outer nested loop. So this is the inner loop. This is the outer loop. So here, this is the inner loop. For B column in the zip of the B, for A row in the A. Okay, this is how the zip function is working. Okay, let me do a more simpler approach. Okay, expanding the zip.
So why you are taking two identical with same order matrix?
Same order. Yeah,
Yeah,
this
yeah.
is correct.
Give a checker. Give a checker.
Give a checker. Yeah, checker will be given. Checker can be given by you guys as well. I'm not doing that right now. Okay, so is this correct? Let me just check it real quick. Mm, yeah. So this is the old algorithm that basically Niket was asking. So first we need to also create the results one.
আমি কি বলছিলাম বলো তো?
This one. Basically here what we do a iteration over the whole matrix, and we during that iteration we take this k value. Okay, and this k value, okay, this k value can again be expanded. Wait, just give me a second. Now this is probably the complete one. This is not exactly. Yeah, we don't. Why is it that it is written? Whatever. Oh, we are not in the function, right? We are outside the function. It's fine. So what we are doing, this is the like old algorithm, not old algorithm. This is the major way of doing it. Okay, this is the base idea of doing it. Base idea of matrix
So why
multiplication.
are we not using it as a main algorithm?
Huh? Why am I?
Why are we not using it as a main? Why you are not using it as the main algorithm?
No, no, this is a base algorithm. I'm just showing you different methods of writing Python functions. So suppose you go to your school, okay, and every day they are actually teaching you that for I in range, for j in range, but you also want to learn something new like this kind of script functions, right? You, so that's what I want
ठीक
you
है,
to थोड़ा सा और भी एक्स्ट्रा
ठीक
कर लो.
है.
तो पहले क्या करो, पहले जो है बेसिकली यू क्रिएट अ 2D मैट्रिक्स, okay, of zeros. So if we just simply do a print statement,
Like null matrix.
it will be a null matrix, correct? So if I just do result, like let me see if I can run this as a cell. Mm, just a second. This is the result, and then let me just print result. Let me run it as a cell. Okay, I don't know if this running as a cell here will work or not. And this one will be another cell. So let's run this cell. Oh, matrix A is not defined. Wait, matrix वो ऊपर वाला कहाँ गया? Matrix A B कहाँ गया? ये ना, नहीं. Yeah, this is the one. Huh? Okay. So I need to initialize this. So then run the cell. This is done. Then, oh, which one? I'm confusing. This run. Then let's go to this one. Yeah. So see, okay, now it is done. Fine. I just initialize the first like values of matrix A and B, and after initializing the first values, we are seeing that okay. Now this the result one. I am printing the result. Okay. I could have used the pretty print. So pretty print. Okay, pretty print is not there. Pretty print. Do I need to import pretty print? I forgot the pretty printing. Okay. Module is not columnar. It is it is pretty print. Okay. Maybe this just check. Yeah, just wait. Check. So how do you do that? Import pp print. Okay. Oh, it is pretty print dot pp. Okay, that's what I was thinking. Dot pp. I need to import. Fine. Chal, run that there. Now, okay, it's still not giving me a good enough आंसर लाइक दिखने में अभी तक उतना भी अच्छा नहीं हुआ पर जो भी हो छोड़ो इट इज अभी अभी के लिए इतना ही छोड़ो सो results are like 0 so initially the results are nothing okay totally given to as 0 now after this what we are doing we are actually trying out different let's say elements of the matrices okay तो पहले हम जो है I मतलब क्या है through the rows we are traversing J means through the columns we are traversing then K is another one which is currently doing a traversal which is not related to I and J. Okay, but understand how it is doing. The resultant matrix I and J means the let's say for I equal to 0, J equal to 0. Like we can open up a simple like doc file. Let's say just for temp. And we just open it to the side. And here we open this file. And basically we have I equal to and J equal to values. Okay. So I is initially 0, J is initially 0. Okay. And then suppose we have a matrix. So we have a matrix like A and B. So let's say the first matrix is let's say 1, comma 2. Okay. And here we have let's say 3, comma 4. Okay. And in the same way we have another matrix.
सैरो मीटिंग है नहीं सैरो मीटिंग है नहीं
Okay. So suppose it is like 6, comma 7 and then it is like 8, comma 9. Okay. Or 8, comma 8, okay, comma 9, whatever. These are the two matrices. Okay. So how are we multiplying it? And just like this, we also have a resultant matrix. Understand the resultant matrix as well. The resultant matrix is totally 0. Like currently it is initialized to 0. Fine. Now, first
তুমি
I
এটাকে একটা
index.
জিনিস বলো why are you taking it as a null matrix I can also take it as an identity matrix or any যা ইচ্ছে matrix
जो तेरा मर्जी ले ले इसमें हजार हजार घुसा दे आई डोंट केयर ठीक है क्योंकि एट द एंड ऑफ द डे द
ठीक है
वैल्यूज विल बी चेंजिंग इनसाइड दिस ओके
हाँ সেটা
फाइन
ঠিক
ओके नाउ अभी आई इक्वल टू 0 सो आई इक्वल टू 0 उसके बाद j इक्वल टू 0 नाउ वी आल्सो हैव अ k अंडरस्टैंड वी आल्सो हैव अ k इज आल्सो 0 ओके now as k I j and k are 0 what is this matrix ai ai and k both of them are 0 so it will basically represent this first element 1 times k times j k times j, now k is also 0, j is also 0. So basically it will be 6. Okay. So 6 times 1. Do you understand? I'm just writing it here. In the first loop, it will be 6 times 1. Okay. And this is added to the 0. So initially 0 was there. So in the 0, you are adding 6 times 1. Now the inner loop will run again. Now this k will now change to 1. This will now change to 1. Okay. As it changed to 1, what happens? ai comma k means row is the same, but k is like k is 1, so it is like 2. Okay, so it is taking the 2 from here, and then it is like bk comma j means it is 1 here, so the row is 1, so the row is 1, but the j is 0, so it is taking 8 from here. So 2 and 8. Okay, so it is taking 2 and 8 and adding it to the result. Okay, so let's add it. 2 times 8. Okay, and it is adding it to the result. So then what is this? This 6 times 1, 2 comma 8. So isn't it like the first element? In the first element, this is like 1. So 1 and 2. This is taking the first row and the first column. Okay, first row of the first matrix and the first column of the second matrix. Do you get it? Now after this, what's going to happen? The k has exhausted, then j will run. So j will now equal to 1. So j will be equal to 1. So as soon as j is equal to 1, what happens? It is a1, no, a is I. So 0 comma k is 0 now. So 0 comma 0. So again we are going to 1. Okay. Then we are going to what? K. Okay, k has been now, okay, let me just write it first. K has been
Sir,
been
একটা
assigned
জিনিস
to
বলতে
0.
আপনি one thing তুমি k
Yeah.
রেঞ্জটাকে why are you defining the range of k as ln matrix of b? It is k রেঞ্জটা ln matrix of b হবে না। The range of k should be the length of the matrix of the resultant matrix. But b is itself a matrix where multiplication is being done.
Okay,
K
okay.
will
See. My point was to go to this part, this try logic. Okay. What you are saying is correct. That it should not be length of B, but currently I'm just taking it as the length of B to make you guys understand the like this part of the logic. वो हम बाद में length calculate
अच्छा
करेंगे. There has to be a separate logic for calculating the length of each and every matrix, and if the matrix multiplication is
ओ
feasible
ठीक
or
है
not.
ठीक है ठीक है
That is different.
ठीक है
अभी देखो यहाँ पे क्या है बी जो मैट्रिक्स बी है उसमें के इज 0, जे हियर इज 1, ऐसा हुआ है के 0 but 1, so 0 but 1 means 7. Okay, so now let's go it. A is 0, I is 0, k is 0, so it is 1 times b का क्या हो गया, b का यहाँ पे 1 comma 0, तो 1 comma 0 means 8, so 1 multiplied by 8. Okay, let me write it down. This is 1 multiplied by 8. Okay. उसके बाद क्या होगा, उसके बाद जो k has to be changed, k has to be changed to 1. Okay, as soon as k is changed to 1, what happens? It is 0 comma 1, so that is 2, and but this is 1 comma 1, which is 9. So 2 plus 9, right? So 2 times 9, so 2 times 9. Okay, and what is this? This is nothing but 1 comma 2, that is the first row of the first matrix, times the second column. Sorry, second column is second what do you call this, row of the second matrix. Okay, is it a row? Wait, it is k is 1, j is 1, this is 9, this is 8, which is correct, and this is, yeah, it's correct. Fine, चलेगा?
Yeah.
Okay, so now this is just an example dry run, and I'm not going like you can do the dry run at your home as well. Is the logic correct or not? Okay, just check if the logic is correct or not. Now after this thing that you are done, you basically just print the results. Now all of this could be done in a single line using the zip command. Okay, I'm just explaining this part. Now, in your school,
बेकार
Dudika,
है रिविजन बाय दिस
huh? Bolo?
this logic algorithm is complicated. Like I thought
This
it was very simple.
no, this is the most algorithm that you do in your class. Okay,
No, no, bro, the above one you just wrote is much more simple
this one is the
using
same
the
thing,
function.
but this is the same thing, but it is using zip.
Yeah, the like
Okay,
that zip function is doing the this thing only, right?
zip function is basically accessing the columns and rows for you. It's you don't need that
Yeah,
extra
yeah.
for k in the range, that extra nested loop.
Uh,
Okay, Judith, I want to specifically ask you to practice matrix multiplication in your school. This will be one of the top things like that will be asked for you to do. Like practical exam में ये सब आता है, ठीक है? Fine, चलेगा? करेगा?
Yeah, okay.
Okay. Now after all these things are done, matrix multiplication हो गया. Now हम जो है numpy में बहुत कुछ कर चुके हैं already, ठीक है? We have done all this matrix multiplication. Yeah. Now this is what matrix operation using numpy. Yes, summation, then difference, then scaling, then product. This is math. This okay. In numpy, you can get the matrix multiplication by using this thing, math multiplication, मतलब math mul. So just इसके अंदर जो है दो मैट्रिक्स को पास कर दो एंड यू आर गुड टू गो. हो गया काम खत्म, ठीक है? मैट्रिक्स मल्टीप्लिकेशन डन using the numpy module. Okay, but you also like Niket was asking me if all of these are already there, why are we so much studying like creating the algorithms from scratch like this, right? But in your schools, in your
to
lower
build the
levels,
thinking process.
yeah, to understand that like how these were created. Okay, so that's there, that's always there. So now इसके बाद क्या होगा? मैट्रिक्स मल्टीप्लिकेशन using numpy. There are okay. Now we are going to go into the transpose. Okay, okay. Dudika, do you know what is a transpose of a matrix?
No,
Yes or no?
no.
No. Okay. थोड़ा सा वो videos देख लेना, ठीक है? But Niket, you have done the transpose, right? What is a transpose of a matrix?
হ্যাঁ রো আর কলাম ইন্টারচেঞ্জ করে দিলে রেজাল্টের ম্যাট্রিক্স যেটা আছে
Correct. Just change, swap the I and J values. Okay, that is transpose. Let me see if I can get 7%. Yeah, this is a good one. Let's see. You just swap the like row and column. In Wikipedia itself, they have a nice animation of it. Okay. दिखेगा? चलेगा? देख रहे हो?
Yeah,
Okay. Now, in the like NumPy application, you basically just call the function uh, matrix dot p. Okay, it's a property of the NumPy array. Dot p मतलब उसको ट्रांसपोज तुम कर दिया, ठीक है? Dot p लगा दिया and then basically it returns. Okay, if it returns something, it returns the transpose matrix. Okay, and that transpose matrix you just catch it in another variable and you can just print it. That's it. That's how transpose is very simple. But suppose I want to do it with my list. Okay, so let's just have let's create a 2D list, 2D matrix. Okay, so let's call it matrix A because matrix A. Now let's say we want to create a transpose. So we can just have a simple function for it. Okay, let me just create a cell for this. So
So tell me one thing, what is this run below does?
this run below.
Yeah.
Run below basically run all the cells like from this point. Okay, run cell means inside this cell only you are just writing. Okay, that's it.
Oh,
Like if I just say run below means, see, currently after this thing there is nothing. So whatever the run cell will do, run below will do the same. But if there are programs
okay.
here, it's not going to touch. Like run cell will not touch other programs. That's it. Okay, let
ठीक
me just
है.
do a print out. Give me a second. Mm, and let's just run it. Okay.
Why are you not using F-string?
What I am not using?
Why are you not using F-string?
Uh, जब मर्जी होगा जब करूंगा. इसका वाई नहीं है भाई. मर्जी हुआ किया नहीं किया नहीं किया. इसमें क्या ज़्यादा है. सो सी, अभी ट्रांसपोज फंक्शन कैसे काम करता है. बेसिकली यू जस्ट स्वैप द आई एंड जे. हाउ डू वी स्वैप. यू टेक द मैट्रिक्स. You instead of like writing I comma j, you just do j comma I, and then just you do it in a loop. Just run the loops and it's done. See, matrix A was 1 comma 2 3 comma 4, but now it is 1 comma 3 and 2 comma 4. So it has swapped along the primary diagonal. Okay, understandable.
So why are you doing that for I in range matrix or ln matrix of 0?
This one.
Yeah.
Okay, let me expand it then. Give me a second. So let's do for I in range the matrix 0 basically means तुम्हारा मैट्रिक्स का पहला रो.
1.
ठीक है,
Okay.
फाइन. मैट्रिक्स का पहला तुम रो ले
Fine.
लो, दैट इज 1,2. एंड बेसिकली उसके बाद क्या है. उसके बाद है कि फॉर j इन द रेंज लेंथ ऑफ द मैट्रिक्स विच इज बेसिकली what is the length here, 2. So then if I is equal to 0 means if the first matrix
But it is matrix underscore A. You are writing a matrix. It is matrix underscore A.
अरे भाई, this is the variable and this is a function, this is a generalization.
Oh, acha. Function. Got it. ठीक है.
Okay, so even if I run it like this, it will still do the
No, ठीक
transposition.
है.
Okay,
Tell
so
me.
if I is equal to 0, then basically you swap it. Okay, if they are not the same, then you don't just so wait. Yeah, but like, okay, this logic doesn't make this is a bad logic. Wait,
No, এটা কি হলো?
wait, just swap. Mm, just swap. It's fine. You don't need to worry about much of them.
এটা ঠিক আছে.
Okay. That was just a random.
I can also do it for I in range lane of matrix. Like lane of only matrix. It will also give me the output too.
That is the length of the matrix. That is different. See, I can predict the length of the matrix.
Length of the matrix too. I know that.
Then, what's the question? This is 2.
No. I am telling that. So y will be varying from y will be the length of row and z should be the length of column. But instead you are setting the range of z as the length of the whole matrix set.
You are asking the. Okay, this one. Oh, it's fine. Let's do it like this. चलो, ठीक है, ये भी चलेगा. That's fine. It will
মানে
work
তুমি
anyway.
এটা কি বলে 2D ম্যাট্রিক্স নিয়েছো বলে এটা ভুল হচ্ছে না, বাট হায়ার অর্ডার নিয়ে নিলে গন্ডগোল হয়ে যাবে.
Yeah, for higher orders, it will be a issue. So that's why it's better to always like stick to the matrix variable. Okay,
হুম.
or just stick to this. Like, yeah, it's fine. It will work. चलो, ठीक है. Now transpose is done. Then inverse of a matrix. Okay, so
স্যার,
inverse.
it
Yeah,
is equivalent to very tiring job. It is also a very tiring job
yeah.
without
So
Kelly Hamilton.
where Kelly Hamilton in finding inverse is a bit tough. I understand. Let me see if I have a good animation. Inverse of a matrix. matrix. I think अभी के लिए इनवर्स का ये समझना थोड़ा सा actually eigenvalue and all this thing will come. Wait, is there an
স্যার
actual
আইগন ভ্যালু তো
solution?
আসে না ইনভার্স করতে গেলে?
Mm, give me a second. Yes, this is a good enough animation. This is a linear equation. Okay, so this linear equation can be represented in form of a matrix, as you can see. 3, 1 and 2, 1, 3, 2, and then 2, 4, 1, and finally the constants. Okay. Now understand this is the augmentation of a matrix. Okay. And then, okay, the Gauss-Jordan
স্যার গস
algorithm.
জর্ডন বাজে ক্রেমার ছিল অনেক ভালো।
No, Gauss-Jordan is way better. So understand
না
what we are doing.
স্যার গস জর্ডন বাজে ক্রেমার ছিল সবচেয়ে ভালো, কি বলছো?
Okay, okay, fine. Famous rule.
না, টেল মি ওয়ান থিং, why are you telling that গস জর্ডন is better than ক্রেমার?
Uh, Depends on the mathematical complexity. Okay. Uh, so the Cramer's rule will require you to find multiple determinants multiple times, right?
কিন্তু গস জর্ডন থেকে অ্যাডজয়েন্ট ইনভার্স বার করতে তো আরো সময় লাগবে।
By hand, not by computers.
আচ্ছা ঠিক আছে।
We are doing computation. Okay. Okay. The Gauss-Jordan rule might be like not understandable to you right now because we are doing various row multiplication operations. So, मैं वही सोच रहा हूँ inverse का concept without going to all the linear algebra का कैसे बोलूँ. Okay. अभी like we
স্যার
can.
এ ইনভার্স ইজ ইকুয়াল টু অ্যাডজয়েন্ট, তুমি ওই লজিকে করো না, এ ইনভার্স ইজ ইকুয়াল টু অ্যাডজয়েন্ট এ বাই ডিটারমিনেন্ট এ।
She doesn't know adjoint. So
তুমি
understand.
অ্যাডজয়েন্টকে এক্সপ্লেন করো, অ্যাডজয়েন্ট তো ট্রান্সপোজ জানলেই তো অ্যাডজয়েন্ট বেরিয়ে আসবে, ট্রান্সপোজ আর কোফ্যাক্টর জানলেই তো অ্যাডজয়েন্ট বেরিয়ে আসবে।
Yes, but currently it will take some level back. थोड़ा सा practice भी करना पड़ता है. Directly, if she has never done the determinant and the like
হ্যাঁ
transpose and all this,
সেটা ঠিক,
okay,
সেটা
directly without a little bit practice, it never goes to the head. Okay, so we are going to skip this part. अभी के लिए थोड़ा सा skip करते हैं. Determinant हमने देख लिया, ठीक है? Determine how to find determinant is fine. Now eigenvalues, eigenvectors, and all this thing we are not going to go into right now. Okay. But the things that we can give you as your homework. Okay, Dudika, have you done the Cramer's rule in your physics?
No.
স্যার ক্রেমার্সেল ফিজিক্সে লাগে না,
लगे ना? किसे लगे?
অ্যাটলিস্ট ক্লাস 11 এ না।
लाग तो हमारे चैनल में.
আরে ফিজিক্সে কিসে লাগবে? ফিজিক্স আমারও কোনো আজ অব্দি লাগেনি।
तारा.
লিনিয়ার ইকুয়েশন সলভে ক্রেমার্সেল লাগে।
হ্যাঁ, এবার লিনিয়ার ইকুয়েশন কোথায় আছে রে?
আর স্যার একটা সত্যি করে বলো,
কিন্তু
ক্রেমার্সেল আমি লাগাই না। লিনিয়ার ইকুয়েশন সলভ করার বেস্ট উপায় হচ্ছে আলফা ইনটু বিটা ইজ ইকুয়াল টু কনস্ট্যান্ট, ওখান দিয়ে ট্রিভিয়াল ইউনিক ইনফাইনাইট ওখান থেকেই বেরিয়ে আসে। ওটা বার করা মাঝে মাঝে ক্রেমার্সেলটাও বিরক্তি লাগে, অতগুলো ডিটারমিনেন্ট নিয়ে বারটা।
because probably most of the time you don't even need the Cramer's rule. So yeah. Okay.
হ্যাঁ সেটাই সেটাই।
How Cramer's rule works. Okay. Suppose you are given a system of linear equations. You know what linear equations mean, right?
Yeah.
Okay. So now in a system of linear equations, you take the constants or let's say the coefficients of the x to the power जो भी है x y j, ठीक है? बस linear मतलब x to the power नहीं, मतलब x y j जो भी variables है, you take the constants and also the pure constant. Okay. Now understand, you know that what is determinant. So you suppose have a simple example of having two linear equations. Okay. Then this is you can take the coefficient matrix, which is 2 and 3, 4 and -1. This is the coefficient matrix. Okay. Then you do the simple computation of the determinant. Then you do the numerator matrix for x. So what is the numerator matrix for x? Basically means that in the coefficient matrix, you change the coefficients for x with the constants 5 and 3. Okay, you change the coefficient for x with 5 and 3, and then you again compute the determinant, which is -8. And you do it for the next one. The coefficient of y is 3 and -1, and you change it with 5 and 3. So you change it with 5 and 3, and this is for the numerator matrix for y, which is giving you the 20, and then you find the determinant of this matrix, which is giving you 22. Then you can find the value of x and y by dividing the determinant of the numerator matrix for x divided by the determinant of the coefficient matrix, and you basically find x ka value and y ka value. So this is the, like, what do you call this, formula, or let's say algorithm for Cramer's rule. Okay, chalega?
Yeah.
But then when can you actually not use it? Suppose the determinant of A is equal to 0. Then can you use the Cramer's rule? No, you can't use the Cramer's rule. So you need to understand when Cramer's rule are actually valid or not. This will be taught in your physics and maths courses this year or next year. I think this year. I remember learning it in, I don't know why, but I remember learning
না
it in
স্যার,
class.
11-এ ক্রেমার রুল করায় না, না ফিজিক্সেও কর। আর তো তুমি আমাকে একটা জিনিস বলো, ফিজিক্সে ক্রেমার রুল লাগছে কোথায়, সেটাই আমি বুঝতে পারছি না।
When you have different pulley equations, linear pulleys and stuff. I remember
হ্যাঁ, তো পুলি তো, হ্যাঁ পুলি স্টাফ ওকে, এনএলএম তো এনএলএম ওকে। আর পাতি পাতি এমনি ওই মাল্টিপ্লাই ডিভাইড করে ওরকম ভাবে সলভ করো, সাবস্টিটিউশন এলিমিনেশন করে।
yeah, I think I remember learning in my childhood. I remember learning Cramer's rule while solving various like acceleration and like that velocity
হ্যাঁ
relation and all that
ওকে,
stuff.
গট ইট, বাট শুধু শুধু দেখো ওই সিম্পল ইকুয়েশন সলভ করার জন্য ক্রেমার রুল বেকার বেকার ডিটারমিনেন্ট বার, তার থেকে তুমি পাতি ইনটু করে
And
সাবট্রাক্ট
like,
অ্যাডিশন করে তুমি ইজিলি বার করতে পারবে।
Are bhai, see, it's not always that you know the simplest method. It's also knowing that there are other things. Okay.
বাট
Okay, listen.
সিম্পল টেকনিক জানারই দরকার।
You know that you can eat rice. You never know the existence of wheat. But now you are accustomed to eating rice. You think that rice
আচ্ছা
is
তুমি আমাকে
everything.
জিনিস বলো, আমি
You need
খেয়ে
to
দিয়ে
understand
কেন
that
ক্রেমার
there.
রুল যেচে পড়ে লাগাতে যাবো কমপ্লিকেটেড জিনিসে, সোজা জিনিসে কেন কমপ্লিকেশন ঢোকাতে যাবো?
Okay, have you solved any of the JEE advanced questions?
দেখো ক্রেমার রুলে আমি ডিটারমিনেন্টসে একটা
No,
অঙ্ক
no,
করেছিলাম
I'm
ক্রেমার
asking
রুল।
you, have you solved any of the JEE advanced questions on like complex pulleys?
কমপ্লেক্স পুলিশ 11-এ করেছিলাম, হ্যাঁ করেছিলাম। কেন বলতো, একটা দুটো হার্ডলি করেছিলাম, জানি না কোনটা যেই অ্যাডভান্স কোনটা কি।
Try solving JEE advanced questions, and there you will find that multiple questions sometimes require knowing the Cramer's rule.
মানে নর্মাল ইকুয়েশন লিখে ইনটু এ করে হবে না বলছো?
It was not probably that easy to solve those equations without Cramer's rule. Determines why they're giving you the faster way of doing it.
আচ্ছা আচ্ছা, ঠিক হ্যায়।
Okay, like I don't know how many questions have you solved in JEE advanced for practicing for JEE advanced.
যে অ্যাডভান্স অত করে প্র্যাকটিস হয়নি, যেই মেন্স ভালো মতো প্র্যাকটিস হয়েছে।
So are you targeting IIT or NIT?
আরে না দাঁড়াও, যেই অ্যাডভান্স আমি মানে অত লেভেলে এখন, আরে অত ঔকাত নেই। আরে 11-এ সবাই শেষ হলো, তারপর তুমি যে অ্যাডভান্স, না যে অ্যাডভান্স এখন অত সত্যি ওপেন যে অ্যাডভান্স অত করা হয়নি।
Okay, try solving those questions, you will find them. Okay, Dutika,
আচ্ছা ঠিক আছে।
try to like practice. Okay, let me tell you, both of you guys are hack. Okay, like that you can get you to solve questions faster. I don't know currently wherever you are taking your coaching classes from, because it is quite understandable that both of you take your coaching classes from PW, Allen, Pathfinder, whatever it is. Instead of going through all the concepts, say, suppose you don't know waves. Okay, currently you are start seeing the questions of waves. I'm giving you a very simple hack. Go to any previous year question paper of JEE Mains. Go to very cheap previous year question paper, PYQ, and just take some random question paper. Try solving it. You haven't read the chapters. You don't even know what the question is asking you to. Take the question, Google out the answer. In the answer itself, it is telling multiple concepts. Take out the answer that, okay, suppose you don't know how, suppose a question from simple harmonic oscillators. You don't know how sine waves and those summation work. Take out the formulas, understand how that one question is asking you to think. Now, repeat the same thing for multiple questions. create a notebook with the concepts that you are like trying to learn by solving the questions. And you know what happens? It will help you to get a like glance over the important parts of the chapters that you are going to learn later. And this will like basically introduce you to all the chapters at once so beautifully and so fast. Okay. This is a hack in basically doing J mains preparation. Um, if you want to follow my advice, you are free to follow. If you don't want to follow, you are also free to not follow. Okay, that's it. So here I wanted to have one more thing. I don't know how much time do we have. This is another module called matplotlib. Okay, so matplotlib say we are importing pyplot. Okay, so in a pyplot module, we are just taking what we are doing. We are trying to create a figure. We are trying to generate animations. We are trying to generate plots. Okay, this is how the plot looks like. This is 3D vector addition. You have two vectors and you try to add it. Okay, so this is u, this is v, and this is u plus v. So as you can see that here this one line with red, one line with I think green or something like that, and you take these two vectors and as you add it, you get this purple vector that is u plus v. Now this animation is created using Python. Okay, as you can see, this animation itself is created using Python, and you can create animations like this as we go along in the course. Okay, so this particular file will be there for you. You can look at it how it works, but this is not for this class. इस क्लास का डिस्क्रिप्शन या फिर discussion में नहीं है, but it is there for you. Okay, so this is probably the end of today's class. Do you guys have any questions, doubts? You are free to ask. Dutika, do you have any questions?
You said you would give some homework.
Oh yeah, homework. Basically this one.
Sir, still
Yeah,
haven't done homework now.
no, we haven't gone to the Gary Hamilton principle. We up to the work that we have done. Kramer's rule. Dutika, this is your homework for you. Especially for you, Niket, if you are free, you have already done this, but you can also do this homework. Take this as a homework. Suppose the user enters equations. Okay, it can be something like this: x, y, z, w, s, t, whatever dimension. The user will input the number of dimensions. Do you want me to write it in some temporary file, or is my like verbal discussion something?
Write it in the README file.
Let me find. Dutika, what do you want? Homework.readme?
Whatever you wish.
But I wish. Okay.
স্যার তুমি যে বলছো আমি এখন যা ভাবছি আমার দেখো কমপ্লেক্স পুরি আশেপাশে রোটেশনাল মেকানিক্সে তিনটে মানে ওখানে অ্যাঙ্গুলার অ্যাক্সেলারেশন লিনিয়ার অ্যাক্সেলারেশন আর টেনশনের একটা ইকুয়েশন ক্যাজরা তৈরি হয়, কিন্তু ওগুলো আমি ম্যাক্সিমাম দেখেছি মানে আগে ভাগে দেশি জুগার লাগিয়ে মাল্টিপ্লাই ডিভাইড করে একটু ক্যাজরা হয় ঠিকই, কিন্তু দেখো 11-এ তখন ক্রেমার্স রুল জানতাম না বলে ওরকম ক্যাজরা ভাবে করতাম আর কি।
Yeah. So take the dimension of the matrices plus equations or system of linear equations. Okay. And as you take the dimension of the like, what do you mean by linear equation? It should be something like some coefficient, say w coefficient plus w coefficient times some variable, say it is something like w, okay, plus x coefficient times x, okay, plus y coefficient times y, plus say z coefficient times z, okay, and this equal to some constant. Okay, now this is one. This is one. Now you might have questions like this. Okay, say this is constant 2. This is say constant 3. Okay, coefficients are also changing. Say this is coefficient. It was coefficient 1. It was coefficient 2. This is coefficient 3. Okay, fine. So you take from the user, you ask the coefficients. Okay, in a particular formatted manner, whatever format you want to take, you take the coefficients and then create the matrices. Okay, from the matrices, you basically whoever's mic is Niket, turn off your microphone. Thank you. From the coefficients that you have taken, create the matrices, and also numerator matrices.
স্যার এই হবে
Ah, matrices. Okay. Create the normal matrix, then create the numerator matrices for, let's say, W, X, Y,
এই
Z.
নিউমেরিক্যাল ম্যাট্রিক্স কি জিনিস
এক্ষুনি তো করলাম। এগুলো কি রে?
মানে
কনস্ট্যান্ট দিয়ে চেঞ্জ করছিলাম, এগুলো কি?
মানে কনস্ট্যান্টলি চেঞ্জ করছিলাম কি কনস্ট্যান্ট চেঞ্জ করছিলাম এই
এই যে
নিউমেরিক্যাল
দেখ,
ম্যাট্রিক্স কাকে বলে
okay, see, this is what in a constant we are taking 2, 4, 3 and -1. This is the
হ্যাঁ
matrix.
ঠিক আছে
Okay, then suppose for x you are changing the coefficients of x with the constants 5 and
হ্যাঁ
3.
সেটা তো ঠিক আছে
Then
সেটা ঠিক আছে হ্যাঁ ঠিক আছে তারপর
this is called the numerator matrix for x.
ও আচ্ছা এটা ও এক্সটাকে নিউমেরিক্যাল ম্যাট্রিক্স বলে সেটা জানতাম না ঠিক আছে
Now you create the numerator matrices for w, x, y, z, or whatever dimension you are working on. Whatever dimension is there. Okay. Remember to make the program dimension agnostic. Remember to make the program dimension agnostic. Okay. Means it should work
স্যার
for
এর মানে
any
কি
dimension. It should work for any dimension, but you will take the dimension from the user. Okay. Then basically you implement the Kramer's rule. Implement the Kramer's rule to find the value of, say, w, x, w, x, y, z, or whatever. Okay, this is your homework. Can it be done?
Can I use zip?
Yeah, use whatever you want.
Okay.
Okay, but one thing, I do have one request to Dutika, not for Niket, that use lists. Okay, use list and implement the algorithms from scratch. Okay,
Okay.
implement the multiplication, sorry, not multiplication. We have implemented determinant algorithm from scratch. But understand that this determinant algorithm is a recursive algorithm, right? So let's, for you to keep it simple, to keep it simple, you will only have 3 dimensions. Okay. What is happening? Fine. Dutika, you will work on 3 dimensions at max.
Okay.
Okay. Something happened. Okay, I couldn't hear what you say. May you repeat?
I said okay.
Okay, fine. So for
স্যার
Niket,
বলছি যে একটা জিনিস বলো।
for you,
হ্যাঁ
yeah,
নিকেত আমার এন ডাইমেনশন সেটাই তো
yes. So
জানি আর কি, তুমি আর
for
ঝামেলা
you,
করার ছাড়া কি করতে পারবে?
for you, it will be any dimension.
কোনো মানে আছে এন ডাইমেনশনে? কি যাতা!
Yeah.
ওকে।
Okay.
আচ্ছা
So
তোমার ওখানে একটা জিনিস বলো, ডিটারমিনেন্টস এ যে রো কলাম চেঞ্জ করলে যে একটা নেগেটিভ সাইন চলে আসে, বা ডিটারমিনেন্টস এ যে ডিটারমিনেন্টস এর
hmm,
যে তোমার প্রপার্টি গুলো, মানে একটা আমি যদি একটা নাম্বার সিঙ্গেল একটা নাম্বার যদি ইন্টিজার বা যাই হোক মাল্টিপ্লাই করে
yeah,
সিঙ্গেল রো বা কলমের সাথে ইনটু হয়ে যাবে, এই সব
yes,
জিনিসগুলো কি নামপাই দিয়ে করা যায়?
yes,
আর পারমুটেশন ম্যাট্রিক্স?
yes. You can create permutation matrix given you need the proper inputs for it. Okay, you can.
পারমুটেশন ম্যাট্রিক্স মানে কি মানে তুমি কি বলতে চাইছো, মানে ধর আইডেন্টিটি ম্যাট্রিক্স এর আমি অপারেশন করে ওটার সাথে একটা ম্যাট্রিক্স ইনটু ইনটু করলাম, এবার
Hmm.
যেই ম্যাট্রিক্স থেকে যেটার সাথে ওইটাকে ইনটু করলাম ওইটার সাথে ওই সেম অপারেশনটা হয়ে গেল, ওই
Yeah.
রকম বলছি আর কি, ওটাকে তো পারমুটেশন বলে
Fine.
আমি যদি জানি।
Fine, fine. That's not exactly the permutation matrix we work with, but yeah, if it's fine, it's fine. You
আচ্ছা
can
বাবা,
you do
আমি
your
যদি
type
জানি
also.
তাই বললাম।
There are different matrices for it, but yeah, this is now okay. Later we can work on uh Jordan matrix, basically Jordan algorithm. Okay, Gauss Jordan algorithm. How to
আচ্ছা গস
implement it.
জর্ডানটা কি মার্টিন্স মেথড গো?
What method?
বলছি গস জর্ডান আর মার্টিন কি একই মেথড? তো মানে ম্যাট্রিক্সে যে মার্টিন্স মেথড আছে, মার্টিন্স মেথড আর গস জর্ডান দুটো তো একই জিনিস বেসিক্যালি বেসিক্যালি।
Matrix.
মার্টিন্স
MATRIX.
মার্টিন্স
Martin.
মার্টিন্স।
This.
ओ लॉल, तो এর लग गए
What is Martin method?
তাই গস জর্ডান। নো, মার্টিন্স মেথড আছে গো একটা, আরে ওটাকে গস জর্ডান বলে বলছি শোনো। তুমি লেখো মার্টিন্স মেথড অফ মার্টিন্স মেথড অফ, হ্যাঁ মার্টিন্স মেথড। আরে তো লগারিদমে চলে গেছে তো।
No, no,
এই
that
তো
is
মার্টিন্স রুল, এই তো ইউটিউবটা দেখো, এই তো ইউটিউব মার্টিন্স রুল।
this one. Let's see.
হ্যাঁ, আরে মার্টিনটাই গস জর্ডান বলছি তো।
System of integration. Then taking the coefficient matrices. Then basically taking the inverse here. What happened in between?
আরে এটাই আমি গস জর্ডানটা এক্স্যাক্টলি মাথায় রাখিনি কেন, গস জর্ডানটা বেকার লেগেছে, ক্রেমাসটা আর মার্টিন্সটা বেকার লেগেছে, ক্রেমাসটা সোজা বেশি। হ্যাঁ এই
Okay.
তো এটাই 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 গস জর্ডান বলছি শোনো।
Gauss Jordan is different. Gauss Jordan is creating the row echelon form of a matrix. That is different.
আমি যাই না, এটা আবার কি বলছো তুমি?
No. Are this is basically like what do you call this?
এটা ক্রেমাস
Yeah,
রুল না।
not Kramer's rule.
কি বলছো
If
স্যার? তুমি
what
তুমি কি লাইভে আছো কিনা বলো তো, সেই বুঝে কথা বলবো, কারণ আছে।
no, it's fine. I'm
তুমি
live.
লাইভটা অফ করো।
Are
না না,
it's
তুমি
fine.
লাইভ
Say
অফ করো।
it's fine. Just say it. You need to understand.
আরে
It's polite to say.
জাস্ট সে দেখো, গস জর্ডান মেথড আছে, গস জর্ডান মেথড দেখো, গস জর্ডান মেথডে হচ্ছে তোমার প্রি মাল্টি এ ইনটু, দেখো কিভাবে বলি, আর দাঁড়াও দাঁড়াও, আরে এখন আমাদের আশিস স্যার যেভাবে করিয়েছে আমি তোমায় সেভাবেই বলছি,
Yeah,
তোমার এখানে
Kramer's rule.
যেভাবে করলো
I
না।
told you. See, this is Kramer's rule. I was telling you that.
না, মার্টিন্স মেথড আলাদা জিনিস, ক্রেমার ছিল আলাদা জিনিস, মার্টিন্স মেথড আলাদা জিনিস।
This is exactly
মার্টিন্স
the
মেথড
same.
জেনে তুমি ইউটিউবে, না আরে কি ক্রেমার ছিল কোনো অ্যাডজয়েন্টের কোনো অ্যাডজয়েন্ট বলে জিনিসটাই ক্রেমার ছিল আসে না, এখানে একটা অ্যাডজয়েন্ট বলে জিনিস আসছে, ক্রেমার ছিল অ্যাডজয়েন্ট বলে কোনো জিনিসই আসে না।
Okay, let me just check.
কিন্তু এখানে
Uh,
কি করে কমনলি আন্ডারস্টুড বলছি আমি জানি না। তুমি বলো
you should
ক্রেমাসিলে
check.
অ্যাডজয়েন্ট বলে কোনো কনসেপ্ট আছে? ক্রেমাসিল পুরো ফুল ডিটারমিনেন্ট কনসেপ্ট, ম্যাট্রিক্সের কোনো কনসেপ্টই ওখানে আসে না। কিন্তু মার্টিন্স মেথড যেটা করছিল ওখানে যে অ্যাডজয়েন্ট আসছে, অ্যাডজয়েন্ট ইজ কনসেপ্ট অফ ম্যাট্রিক্স।
Let me see.
আর আর তাহলে তুমি লাইভে আছো কিনা বলো, তুমি লাইভটা অফ করো না।
No, I'm not in live. Okay, fine. Now think.
আচ্ছা তাহলে লাইভে নেই তো, তাহলে কথা বলবো, লাইভে নেই তো।
আরে বল বল।
আরে আমাদের পিডব্লিউ তে আশিস স্যার তো গস জর্ডান মেথড আর ম্যাথমেটিক্স একই তো বলেছে।
Hmm.
আমাদের
Let's
পিডব্লিউ তে
see.
যে আশিস স্যার যে পড়ায়, সেটা
See.
বললো
I
গস জর্ডান
I
মেথড আর
I don't know which rule you are talking about. Martin's rule. Whatever that say, that was. This thing is basically your Kramer's rule that was doing. But give me a second. I don't know Martin's rule. I do not know
স্যার,
what is Martin's rule. I need to check. Okay, I'm hearing this
আমি তোমায় বলছি না।
name for the first time. Just give me a second.
স্যার দাঁড়াও দাঁড়াও, আমি তোমায় আশিস স্যারের যে পিডিএফটা পাঠাবো যেখানে বেসিক্যালি গস জর্ডানটা পড়েছি, আর ওখানেই বললো যে গস জর্ডান আর মার্টিন্স মেথড এক জিনিস।
Hmm. Maybe if he's saying it, then it might be correct. I need to check. I don't know what is Martin's rule,
না
so
না না
I
দাঁড়াও,
do not know. I'm telling you that I do not know Martin's rule, so like
আরে
need to
তুমি
check.
জানো, আরে মার্টিন্স রুলটাই গস জর্ডান রুল বলছি তো। দাঁড়াও দাঁড়াও, আমি তোমায় এটা পাঠাচ্ছি, তোমায় ছবিটা পাঠাচ্ছি আমি কি পড়িয়েছে, তুমি চেক করো হোয়াটসঅ্যাপ। দাঁড়াও তুমি হোয়াটসঅ্যাপ চেক করো, পেয়ে যাবে। আমি এক্ষুনি পাঠাচ্ছি।
Fine,
ওয়েট,
fine.
এই তো হয়ে গেছে,
Okay, Dutika, this is a different
চেক করো।
discussion which is going on. You might stay. You are free to leave at this point. Okay, the class is over. So, by the way, just before solving Nikit's doubt with Martin's rule, do you have any doubt for today's class?
No.
No. Okay. Then, if you want to stay during this discussion, you are free, whichever be your choice. Okay. I
তুমি চেক
never
করো,
heard of
হোয়াটসঅ্যাপ চেক
this.
করো।
Yeah, my WhatsApp is opening. Just give it a sec. Yeah,
হ্যাঁ
you
শোনো
have sent a
চেক।
picture. You have written. Okay, picture is just hazy, but okay.
হেজি কি গো? আরে নেটের জন্য হেজি, পুরো এসএস তুলেছি, হেজি হতে পারে না।
It is taking the adjoint. Yeah, যেটা আমরা দেখলাম। হুম।
আরে এটাকেই তো ওরা গস জর্ডান বলছে। আর আমাদের আশিস স্যার বললো গস জর্ডান আর মার্টিন্স মেথড এক জিনিস।
Tell me, is this the same?
দাঁড়াও এক মিনিট। For example, swap the position of first row.
Oh wait, you are talking about Gauss Jordan?
আমি এলিমিনেশন কিন্তু গস জর্ডান এলিমিনেশনের কথা বলছি না কিন্তু, আমি
Huh?
বলছি গস জর্ডান মানে ওয়ে টু সলভ দ্য লিনিয়ার সিস্টেম অফ ইকুয়েশন, সলভিং লিনিয়ার ইকুয়েশন। হ্যাঁ, বারবার
Yes.
এলিমিনেশন চলে আসছে, এলিমিনেশন না কিন্তু। সেকেন্ডে যাও গস জর্ডান মেথডে যাও। না তুমি গস টু ফর্ম না, হ্যাঁ টু সলভ লিনিয়ার ইকুয়েশন। হ্যাঁ হ্যাঁ, ফার্স্টে যাও। হ্যাঁ ওটাই। হ্যাঁ, এবার দেখো তুমি বারবার এলিমিনেশনে চলে যাচ্ছে।
Okay. Let it load.
এটা কিছুই দিচ্ছে না।
It will load. It is still loading.
এখনো লোড হচ্ছে।